Welcome to the chapter overview of chapter number 1, Number Systems, based on the NCERT Class 9 textbook. In this video, we will explore how the concept of numbers progressed and how the real number line was fully constructed. The mathematical progression of number systems began with counting numbers. Adding the 0 point led to whole numbers. Then, the negative mirror of counting numbers resulted in integers. Finally, adding fractional gaps between integers completed the set of rational numbers. The rational universe is built layer by layer. We start with natural numbers, add 0 for whole numbers, introduce negative values for integers, and include fractions for rational numbers, which can be written in the p by q form, where p and q are integers, and coprime. Around 400 BC, the Pythagorean crisis emerged when quantities like the diagonal of a unit square, the square root of 2, could not be expressed as a simple ratio of integers. These were named irrational numbers. The Cantor-Dedekind principle mathematically proved that the combination of rational q and irrational I numbers completely fills the number line, resulting in the real numbers r. Irrational numbers can be precisely located on the number line using geometry. Starting with a unit square, the hypotenuse is the square root of 2. Using a compass, this length can be dropped to point P on the number line. By continuously adding perpendicular unit-length segments, we can create an infinitely expanding spiral that geometrically illustrates various irrational and rational square roots. The decimal fingerprint distinguishes between number types. Rational numbers either terminate or have a repeating decimal. Irrational numbers, however, are non-terminating and non-recurring. A recurring decimal can be converted to a fraction p/q by using algebraic steps, such as setting the repeating decimal equal to x and then subtracting to solve for x. When interacting, adding or subtracting a rational and an irrational number always yields an irrational result. Similarly, multiplying or dividing a non-zero rational and an irrational results in an irrational number. However, operations between two irrationals can result in either a rational or an irrational number. The universal geometric root construction provides a method to find the square root of any positive number x geometrically, using a semicircle and a perpendicular line segment. Restoring rationality to a denominator involves a tool called the conjugate pair identity, which simplifies expressions like 1 divided by 2 plus square root of 3 into a rational denominator by multiplying the numerator and denominator by the conjugate. The extended laws of exponents define how exponents interact with multiplication, division, and powers. It also introduces the fractional exponent, which is related to roots. In summary, the number system hierarchy shows that all sets are subsets of the real numbers. The decimal matrix distinguishes rationals from irrationals, and specific rules govern their interactions, such as those involving conjugates. Thank you for learning with us, and see you in the next chapter overview.